All right, 11.2, we're going to be taking the derivative of trig functions. So in theorem 11.3, we have the derivatives of sine and cosine. The derivative of sine is cosine, and the derivative of cosine is negative sine. So you're going to have memorized the 6 trig functions and their derivatives. So these are the first 2 that we're going to look at. So in example 1, we want to find each derivative. So we have 3 times sine. So our derivative, we take the derivative just as if this was an x or just a variable, but instead it's a special variable, it's sine. We know that the derivative of sine is cosine, and that coefficient is just going to stay out front. So we have 3 times cosine of x. This would be our derivative. For b, super similar, but we have sine of x over 2. They simplified it for us because it's easier to see when we have 1/2 times the sine of x. So a lot of people will look at this and think, oh, we're dividing, I got to do the quotient rule. No, 2 or 1/2 is just a coefficient. So we just leave the coefficient out front, and our derivative of sine is cosine. So it'd be 1/2 cosine of x. For c, we're doing the same thing, but we want to take the derivative of each term that we have. So what's the derivative of x? 1 plus, what's the derivative of cosine of x? Negative sine, so instead of plus, let's make this a minus. So minus sine of x. So this would be our derivative. So example 2, we're going to find the derivative. Same thing, we want to take the derivative of each term. However, in our first term, we've got 2 things that we're multiplying here. So what would I have to do here? For multiplying, the product rule. So we have the first times the derivative of the second plus the second times the derivative of the first. So our first is 2x times the derivative of the second. What's the derivative of cosine of x? Negative sine of x plus the second, cosine of x, times the derivative of the first. What's the derivative of 2x? 2. So I'll put that 2 as a coefficient there. Minus 2 times the sine of x. Oh, just kidding. I didn't even take the derivative of that one yet. What's the derivative of sine of x? Cosine x. Awesome. So that coefficient, that minus 2 or negative 2, just stays out front, and it would be cosine of x. So we took the derivative of everything. Let's simplify a little bit more. So I have my derivative. Here, I want to simplify, just put the negative out front. So negative 2x times the sine of x. And then what's 2 cosine of x minus 2 cosine of x? What happens here? What happens here? They cancel. Awesome. So this would be our derivative. Example 3 says find the slope of the graph of f of x equals 2 cosine of x at the following points. So it gives us just one function and 3 different points that it wants us to find the slope. So let's find the derivative of our function first, then we can find the slope at each point. So our derivative, I'll call it y prime, would be 2 times, what's the derivative of cosine? Negative sine x. So I'm going to put that negative out front. So negative 2 times sine of x. So we're going to use the same derivative for each one. So our derivative is negative 2 sine of, what's our x here? Negative pi over 2. So to find what our slope is, we have to look at our unit circle. So negative pi over 2 is not on our unit circle, so be careful. Instead of going up pi over 2 in this direction, since it's negative, we're going to go down pi over 2 in this direction. So negative pi over 2 is actually 3 pi over 2. You could always find a coterminal angle of it just by adding 2 pi to it. So you could see how far it goes in the positive direction and then just do that same distance in the negative direction, or you could just add 2 pi, find a positive coterminal angle. Sine tells us we look at what, the x or the y? The y. So our y is negative 1 here. So we would have negative 2 times the sine of negative pi over 2, we said is negative 1. Negative 2 times negative 1, 2. So our slope would be 2. Awesome. Let's do the same thing with b. So again, we're using our same derivative here, but now we just have a different x value. What's our x value for here? Pi over 3. If you want to think about it this way, you can. It doesn't really matter how we write it, but f prime of pi over 3 would be negative 2 times the sine of pi over 3. So let's look at our unit circle. Let's find what the sine of pi over 3 is. We're going to go to pi over 3. Sine tells us we look at the y value, so square root 3 over 2. So we have negative 2 times square root 3 over 2. So this would give us a slope of what? Negative square root 3. Awesome. And then let's do the same thing for c. So here we're finding f prime of our x value is pi. So negative 2 times the sine of pi. Let's go to our unit circle, find the sine of pi. Pi is, or the sine tells us we look at the y value. So it'd be 0. Sine of pi is 0. So we have negative 2 times 0. So what's our slope here? 0. Awesome. Just for fun, let's say that A told us to come up with a tangent line at this point. So let's find our tangent line. We have the slope of a tangent line. I have a point on my tangent line. So how would I come up with the equation of a tangent line? We're going to plug it into point slope form. So y minus y1 is equal to m times x minus x1. So y minus 0 is equal to 2 times x minus negative pi over 2, so that turns into plus pi over 2. We could simplify here. I'm going to distribute, so we have y is equal to 2x plus pi. So that would be our equation of the tangent line. So we just take our slope that we found and the point that it gave us, plug it into point slope form. On the next page, it graphs the function for us. This is the graph of 2 cosine of x. And then at each point, so our first point for A was negative pi over 2, 0. The tangent line, is it increasing or decreasing? It's increasing, which makes sense because we had a positive slope. For B, our point was pi over 3, 1. Our tangent line, is it increasing or decreasing? Decreasing, which makes sense because we had a negative slope. And then for C, our point was pi, negative 2. And here, we had a slope of 0. It's a horizontal line. So theorem 11.4 has our other 4 derivatives of trig functions. So these you have to have memorized too. So in addition to sine and cosine, we've got tangent, cotangent, secant, cosecant. So the derivative of tangent is secant squared. Cotangent is negative cosecant squared. The derivative of secant is secant times tangent, and the derivative of cosecant is negative cosecant times cotangent. And then the other two that we had were the derivative of sine was cosine, and then the derivative of cosine was negative sine. So all 6 of these you need to know. You need to memorize them. It's not too tricky to memorize them once you start to kind of see the patterns of it. One thing that I like to think about that helps me keep the signs in line is every derivative that I'm taking that starts with a C. So cosine, cotangent, cosecant, those are my negative derivatives. So that's just one little trick, but just notice the patterns between the 6 trig functions and it makes it a little bit easier to memorize. Example 4, we're going to find the derivative. So here we're going to take the derivative of each term. So what's the derivative of x? 1. What's the derivative of tangent of x? Secant squared. So this would be minus secant squared x. Perfect. What do we have to do for b? Product rule. We've got 2 things that we're multiplying, so we have to do the product rule. The first times the derivative of the second plus the second times the derivative of the first. So we have x. What's the derivative of secant of x? Secant x tangent x. Secant tangent. Plus the second, so secant x, times the derivative of the first. And what's the derivative of x? 1. So this would be our answer. I think WebAssign's okay with you leaving it like this. You could take out the secant. If we did that, we would have secant x times tangent of x plus 1. So these are the same. It doesn't matter how you leave it. Either way is fine. And then let's look at C. Be careful with C, because cosine of 3 doesn't have an x in it. So this is technically just a constant. What's the derivative of any constant? 0. Awesome. So this would just be 0. And then what's the derivative of x squared? 2x. So our derivative would be 2x. If this had parentheses, and we were taking the cosine of 3 plus x squared, it would be different. But here, it doesn't have parentheses. We're just taking the cosine of 3. So because this does not have an x, it is just a constant. So our derivative would just be 0. Example 5 just talks about how we can differentiate both forms of this. So these are equivalent. 1 minus cosine over sine is the same as cosecant minus cotangent. If I were to split this up, I have 1 over sine of x minus cosine of x over sine of x, which gives us cosecant minus cotangent. So these are equivalent. You could take the derivative of this way using the quotient rule, or you could just take our derivative of this, taking the derivative of each term. You'll end up with the same answer, but there'll be more simplifying involved in the first one to try to get it to be as simplified as the second one. So it doesn't matter if you simplify before or after. I would recommend simplifying it this way first. That way taking the derivative is easier, because it's going to be easier taking the derivative of just 2 terms versus doing the quotient rule and then simplifying. Next, these are the same 6 trig functions, the derivatives of the trig functions. But when we have something other than just x in our trig function, we're doing a version of the chain rule, so chain rule versions, where we have to multiply by the derivative of what we're taking the trig function of. So if I had something like cosine of 3x my derivative of this, what's the derivative of cosine? Negative sine of x. So here it'd be negative sine of 3x because the inside part stays the same. And then we multiply it by the derivative of the inside. So what's the derivative of 3x? 3. So times 3. So it'd be neater just to write it out front. So we've got negative 3 times the sine of 3x. So this would be our derivative. So it's similar to the chain rule where we're taking the derivative of our trig function. What we're taking the trig function of, so what we're taking the cosine of stays the same, and then we just multiply it by the derivative of that, what we're taking the cosine of. So here it just says the derivative of sine of u would be cosine of u, so that u stays the same, and then we multiply it by the derivative of u. So it's similar to just u prime times cosine of u, if you want to think of u prime as the derivative of u. All right, so example 6, we're just doing more derivative practice. So here, our derivative, what's the derivative of sine? Cosine. So we've got cosine of 2x, the inside part stays the same, and then we multiply it by the derivative of 2x. What's the derivative of 2x? 2. So we've got 2 cosine of 2x. Let's do b. I'm going to change b to be x squared minus 1 just to make it a little bit different for us. So our derivative would be, what's the derivative of cosine? Negative sine, so we've got negative sine. The inside part stays the same, so x squared minus 1. And then we multiply that times our derivative of the inside. What's the derivative of x squared minus 1? 2x, awesome. I'm going to multiply that out front here. So put the 2x there. So we've got negative 2x times the sine of x squared minus 1. Any questions here? All right, C. What's the derivative of the tangent? Secant squared. So secant squared e to the power of x, the inside part stays the same, and then we multiply it by the derivative of the inside. What's our derivative of e to the power of x? E to the power of x. So we've got e to the power of x times secant squared e to the power of x. So this would be our derivative. Any questions here? So for A, in example 7, what's the derivative of the cosine? Negative sine, perfect. So we've got negative sine of 3x squared. What's the derivative of 3x squared? 6x, perfect. We'll put that out front. So we've got negative 6x sine of 3x squared. Be careful with B. Cosine of 3 does not have an x in it. And it's just the 3 that we're taking the cosine of. We're not taking the cosine of x squared as well. That x squared is just being multiplied. So when we take the derivative here, cosine of 3 is just a coefficient. So same derivative rules that we're used to doing. We multiply the exponent times the coefficient. So we've got 2 cosine of 3. And we subtract 1 from the exponent. So times just x now. So that cosine of 3 is just a coefficient. Multiply the exponent by the coefficient, subtract 1 from the exponent. Any questions here? Okay, let's do C. What's the derivative of the cosine? Negative sine, so I've got negative sine of 9x squared. And then what's the derivative of 9x squared? 18x, awesome. So negative 18x times the sine of 9x squared.
Why does it have cosine 3x?
these are the same here and here. We could treat it the same, but it simplified it before we took the derivative because it's going to be easier, because if we didn't simplify it, then we would have to be doing the chain rule of this. We'd end up with the same answer, but it's just going to be easier because it's just 3x that we're squaring. It's not the cosine squared. So notice the difference between C and D, where D is cosine squared, where the squared is on the cosine. So it just squared the 3 and squared the x, and that's how we got the 9x squared. So for D, the cosine's being squared. So we have cosine squared of 3x. You'll usually see it written like this, where the squared is on the cosine. I think it's easier to kind of see it this way, where it's the cosine of 3x squared. So these mean the same thing, but when it has parentheses squared, when we see those parentheses, we usually associate the chain rule with it, which is what we have to do, because cosine is being squared, so our function is being squared. So when we do the chain rule, we take the derivative of the outside, so 2 goes to the front, the inside stays the same, cosine of 3x. Subtract 1 from the exponent, so our new exponent is just 1. Then we take the derivative of the inside. What's the derivative of cosine? Negative sine of 3x. And then we take the derivative of what we're taking the sine of. What's the derivative of 3x? 3. We can write this a little bit neater. We've got 2 times 3, which would be 6. Times a negative here too, so negative 6 times the cosine of 3x times the sine of 3x. So that would be our derivative.